All right, my name is Greg Endres. I work as extension agronomist out of the Carrington Research Extension Center. And there's some selected agronomic topics that I'd like to share with you during my brief presentation. And so here's the subjects I want to cover, and they include a couple in soils. I want to talk a little bit about the tillage systems, a bit about saline soil tolerance by sunflower, and then a number of subjects within plant establishment, including crop rotations, a bit on planting dates, and then we'll look at growth stages and some management considerations. Hans had alluded to the sunflower survey. I think all of the NDSU extension speakers will be doing that today, using some of the survey results as at least an introduction to their subjects. And so I've been involved with the field survey for quite a few years. And I thought I'd share a couple of pictures showing some of the extension agents that I worked with. And so I'm going to use a bit of the data from the survey for introducing some of my subjects. I want to point out the smiling faces on these folks. I think they enjoy being out there, and it's a wonderful in-service training for people to learn more about sunflower. And so this is just an overview of the survey data, and I'll be focusing on a couple items within the agronomic information. All right, so this is a pie chart that for some reason is not being displayed correctly, but I'll try to work through it anyway. The green part is, well, this is the survey results on tillage with the sunflower fields that are visited. And the green and yellow indicate the conservation tillage. The green is no till, the yellow is reduced till, and then the black is conventional till. So we're very pleased that we have nearly 75% of the fields we visited were under some type of conservation tillage. And probably the reason for that is with sunflower, oftentimes it's not on the highest productive lands, probably ground that has more coarse textured soils, low organic matter. And so we're very pleased that we're using no-till or reduced till for much of the sunflower production. And that differs compared to dry bean. Each year we survey dry bean growers and on many things, including the tillage system, and it's just the opposite. There's a vast majority of dry beans grown on conventional tillage. Okay, and then we've done some work with tillage systems. As an example, this is work we did at Carrington during 2006 through 9. And very simply, we compared fall strip tillage and direct seeding into small grain stubble compared to conventional tillage. And note that by using these reduced till systems, that we did not have a negative impact on yield. With strip tillage, that was the main focus of this work. There is strip tillage came into the state, I believe, in the early 2000s. There's a lot of interest in 2004 through the balance of the decade, and so we were pleased to be able to generate some data to help support that type of tillage system. I'd like to tell you more about that, but the time is limited today. But I will point out that we do have an extension circular on strip tillage that gives a lot of good basic information. It's a joint effort by NDSU and University of Minnesota Extension. If you want to look at the information, a simple web search with the keywords NDSU strip till should get you there. Okay, the next soil subject, I want to talk briefly about saline soils and impact on sunflower production. As a starting point, this is a map generated by AgVice, just showing from the soil analysis the percentage of samples in a region within states on those soil samples that had salinity above 1. And this would be with the 1-to-1 test. And so you notice across the region, there's a fair amount of concern in North Dakota, especially in the eastern part of the state. We have a lot of soils that have EC of concern for those susceptible crops. We have a very nice extension circular called Managing Saline Soils in North Dakota. The web search, just type in NDSU saline soils. Anyone that has concerns about salt-affected soils should have this publication. Within it, there's a lot of information, including a table that shows the approximate reduction in yield with various crops and based on EC levels. So looking at sunflower, notice that the threshold, the approximate threshold salinity is 0.75 EC. And note that's actually quite similar to some saline soil susceptible crops such as soybean or dry bean. And note that if we just go up to 1 EC, the estimate is there could be up to 10% yield reduction. So sunflower, at least initially, is quite susceptible. We do know that once the plants are established, the tolerance goes up. In particular, if we have topsoil moisture that has adequate soil water, as well as having adequate plant nutrition. So this table, or this graph, just shows the same thing as what the prior table did. So the question is, what do we do with sunflower if we have some salt-affected soils? And very simply, we'd like you to identify those areas, soil sample, and find out what the EC is. And then the management-wise, we certainly want something growing on that ground. Ideally, if we could find a tolerant cash crop, that would be best. But if we see white out there, it might indicate that we're going to have to go to a perennial grass in order to have some ground cover out there. So irregardless, it's very good to identify these areas, keep them in check by growing a compatible or tolerant crop. If we don't, we're putting a lot of dollars with inputs across these areas with very little or no productivity. And very likely, those areas will expand in time. All right, now let's move into plant establishment. And so the first thing I'd like to mention is crop rotation or crop sequencing. So back to our survey, the results for North Dakota this past season show that about 2/3 of the fields that were surveyed that with sunflower, the previous crop was a small grain, primarily wheat. The second was corn, and third was soybean, and then there's a smattering of other crops. So I think it's pretty logical with sunflower on small grain ground. With corn, there might be some advantages, including the ease of direct seeding between the corn rows from the previous crops. Might be an opportunity to make use of some nutrients that the corn didn't use, and maybe even subsoil moisture that the taproot of sunflower can reach that the corn did not. And there's probably other reasons too for corn being a fairly popular previous crop for sunflower production. I am surprised that there wasn't a larger soybean acreage or percentage of soybean where sunflower growing on it, but we'll see what the future holds. But next, I'd like to show you a couple of slides just showing some research data on the crop sequencing. So this is some older data from Mandan, a site where typically they have lower soil moisture levels. And note where sunflower was growing on spring wheat ground, that was actually the highest yielding. I didn't show another crop, field pea, but the field pea also was a very good environment, and similar to the spring wheat on sunflower yield. Note with canola as the previous crop, the sunflower yield was down some. Part of the reason may be that canola is not very mycorrhiza fungi supportive, and so maybe there was less nutrients available, or in particular, there may have been less phosphorus available for the sunflower, amongst other reasons. And then no corn, there was a reduction in sunflower yield with corn as a previous crop in this database as compared to a small grain. And as you would suspect, sunflower is a very bad strategy. That was North Dakota. This is some Manitoba data. This is a 7-year average of commercial fields where they looked at the impact of prior crops on many crops, including sunflower. And so what's interesting is notice the production with sunflower on small grain. In particular, it was good with spring wheat and oat, a little bit less for some reason with barley. But I also like to point out the sunflower response on corn ground. That was different compared to the North Dakota data that I showed you. Also notice soybean. Soybean performed, the soybean ground performed as well as the spring wheat ground. And then I'll point out the sunflower and sunflower, not as dramatic yield reduction in the Manitoba data compared to North Dakota, but again, certainly not a good strategy. Moving on, I'd like to talk a little bit about planting dates. This is a graph showing last year's Ag Statistics survey of planting progress with sunflower. And note that the survey indicated some fairly early planting last year. Of course, we had a relatively early season and certainly dry soils and to provide opportunity for some people to plant early. But notice that when we got to the latter part of May and into mid-June, that's when the bulk of the planting was done, as we would expect. And then once we got into mid-June, then the planting pretty well stalled out. So is that a good strategy? Well, let's look at a little bit of research data. This is some data from Carrington for your average, looking at planting dates of sunflower from May 1 until latter part of June. And in this database, it's indicating that planting the last half of May would provide the best opportunity for a yield increase. When we plant earlier, there are some concerns. One might be soil temperature. We'd like to see a consistent soil temperature of 50 degrees. Planting early does pose, in my opinion, some increased risks with pests, in particular insects, because as the early planted crop progresses, it might be actually a magnet. If it's the earliest flowering sunflower field in the region, a magnet for the head infesting insects. Or toward the end of the season, it might be the first field that reaches maturity. It might be a prime target for blackbirds. So those would be a couple concerns with early planting, as well as potential for not quite as high yield potential. Hans and I have recently revised a publication titled Replanting or Late Planting Crops. And in there, we do have some references to sunflower. Here's a table contained in the publication, which, by the way, can be searched on the web using the keywords NDSU late planting. And notice in this table 3, expected yield reductions with late planting of some of our major row crops, including sunflower. With sunflower, our rule of thumb is a yield loss per day of about 1.8% if we're planting into June. So the good thing is that sunflower certainly will perform well in June. We don't have a lot of crop choices when we plant that month, so we still encourage sunflower planting during that time, but keep in mind that it's not the optimum yield time. One other concern too is with planting well into June is that if we would have an early frost and terminated the crop before full maturity, besides yield loss, we also are concerned about having reduced oil content, because oil would be the last component placed in the seed. Okay, well, NDSU does have a sunflower production guide. We revised that not very long ago. And if you want to take a look at that, web search would be using the keyword NDSU sunflower. This circular is probably the largest that we offer to clients within at least crop production. And so it has a lot of information available for your use. So within the guide, we do have the stages of sunflower development. As a grower or a crop consultant, if you're not aware of the stages or very familiar with them, we'd encourage you to do so, because it's important to know these. As an example, with pesticide application for herbicides, there's a number of post-herbicides where the crop staging is important. And on the other end of the life cycle of sunflower, it's very important to be able to determine the physiological maturity if a person plans to apply a pre-harvest desiccant. And then in the middle of the crop staging, Jan probably alluded to this when she talks about insect management, but certainly it's important to be aware of the various bloom stages, as we consider insecticide application for our head infesting insects. Also in our production guide, we do have some rule of thumbs on development of sunflower, both by days as well as by growing degree day units. And so as an example, during the vegetative stages for sunflower, the survey data, I was actually the one that did the work over the years. It on average, it showed just under 50 days from planting until the R1 or bloom stage. With growing degree day units, on average across the database, we found around 900 units were required to go from planting until R1. Also note that the base temperature with growing degree days for sunflower is 44 degrees. And then with the reproductive portion of the life cycle of sunflower, on average, we found about 70 days to develop from R1 until maturity, and about 1,600 growing degree day units. NDON has a nice feature to help you with estimating sunflower development using growing degree day units. Simply go to the NDON site, choose applications, choose sunflower growing degree day units, and then put in the planting date, and that'll give an estimate of the crop stage. That might be useful if you have fields that are a considerable distance from your home base, and you just need at least a rough estimate if you're planning on, for example, some pesticide applications. All right, so we have quite a range in stages in sunflower. The pictures depict on the left-hand side a V4 stage. That's determined when the individual leaves reach a length of about 2 inches or greater. So V4, and then the other picture is a nice shot of a head that's at physiological maturity. That would be R9 stage, when the back of the head has no green, is yellow, and the bracts have no green. And they can range from yellow all the way up to black in color. So wouldn't it be wonderful for those of you that grow sunflowers or consult that we had uniformity like this in a field? But that does not happen. And that's the challenge with determining physiological maturity in sunflower. It seems like that crop is even more variable as compared to some others. Well, where I'm going with this is that I'd like you to think about what is the critical growth stages for sunflower, where we want to have minimal stress and have all of our management factors in place. And so you may think flowering, and that's partially true. This is a table that's in our production guide that shows the approximate yield loss based on leaf area that's destroyed by various reasons and based on crop staging. But we can take this further and say that any type of stress, we can see impact on yield loss. And so what I did is I drew a rough line separating the single to double-digit yield reduction. And notice as you follow the line, the top of the peak is actually an R3 stage. R3 stage is, of course, pre-bloom. It's when the uppermost leaf on the stem is at least 2 inches from the base of the head. And so actually the critical stage for minimizing stress on sunflower ranges from R2, where the uppermost leaf on the stem is just below the head, all the way to R7 stage. And that's where we start to lose some green color on the back of the head. So during this period would be the critical stage. It's about 50 days. And the most critical period would be from that R2 stage up to bloom. So please keep that in mind. Basically, we want to have our management practices in place and be controlling any pests that are out there, and of course hope for no hail or other problems that may occur. I'm going to close by saying that South Dakota State also has a nice production guide. In fact, they borrowed some information from NDSU. And so you guys have two very good resources from NDSU as well as South Dakota State to review and hopefully utilize as you you grow a sunflower crop or for crop advisors as you assist growers with their management.